Hello, welcome to Math 252 Calculus 2 here at Cañada College. My name is Lapuz. In this video, we'll be doing checkpoint 3.17 from section 3.4, partial fractions. They want us to evaluate the integral of x minus 3 divided by x plus 2 dx. And looking at this expression, it does not quite need the partial fraction decomposition treatment. However, it's still not so easy to integrate as is, so we want to rewrite this algebraically into something else that we can integrate. One of the key things to look for is if you have a rational function that's a polynomial divided by a polynomial, we want to look at the powers of, or the degrees of the polynomial on top and the bottom and compare them. If the degree in the bottom looks like it's larger than the degree on top, then we can do some decomposition or whatever else we need to do. But if the degree on top is bigger than or equal to the degree on the bottom, then there's some things that we can do to split up your integral. One way to look at it is if your degree on the numerator is bigger than or equal to the degree in the denominator, you can do long division so that we can have a degree in the denominator larger. So long division, let's do a quick side view or side work over here. X minus 3 divided by x plus 2. And when we want to match up the first terms, x, I want to multiply this by 1. And so that's just going to be x plus 2. And I subtract the whole expression, then this will be 0, which is our whole point. And this is a negative 3 minus 2, so that's a negative 5. That means that we will have 1, and then we add negative 5 divided by the denominator. Okay, that means our integral will then become the integral of 1 plus negative 5 over x plus 2. And this is now something that we can integrate. The integral of 1 is just going to be x. The integral of the next term will be an ln term. Another way, just to kind of give another method here. It's not really a method, it's more like an algebraic repositioning of some values. And the idea is that, again, the powers match up, or they're linear terms. They're both linear terms on the top and the bottom. What we can do is we can keep the denominator's fraction the way it is, and then we can set the numerator to have an x plus 2 plus something else. Which means if we take this negative 3 and we write it so that we have a positive 2, and we ask ourselves, what do we need to add so that this will be equal to negative 3? So I think if we add negative 5 to this, we'll get negative 3. And so we can split this negative 3 up into plus 2 and then minus 5. Now, I can split the fraction up into two fractions now, and then this will give me a fraction x over x plus 2 divided by x plus 2, which is 1, and then this will give me another fraction of negative 5 over x plus 2, and we'll get the same result. So either way you do it, I think this method here that I just showed you is not very intuitive, and this method over here, it will always work. It's kind of a surefire way to make it work. In either case, we get the same integral that we're going to integrate, and so the antiderivative of that is just going to be x. The antiderivative of 1 is x. The antiderivative of anything over x, or if you have a linear term, it's going to be antiderivative of that. it's going to be a u substitution. U equals x plus 2. du is going to equal to dx. So this is going to be 5, the negative here too. U du, and then that's going to be an ln function. So that's going to be negative 5 ln of u. All right. So u is equal to x plus 2, so this is going to be negative 5 ln of x plus 2. And let's keep the absolute value there just so we can, the absolute value being dropped or kept will depend on the limits of integration, so we don't have limits of integration, so we'll keep the absolute value there. And then we have the plus c, and that is our result. That's our answer. Okay, I hope that helps. Good luck.